Good morning, students. I hope all of you are fine. So let's continue with the chapter which we have started earlier, that is Human Eye and Colorful World. Now students, in our previous class we have discussed about the atmospheric refraction. Now today we will discuss about another topic which is called scattering of light. So students, scattering of light means it is a process in which light is transmitted in all directions when it is incident on a particle which has greater diameter, that is called scattering of light. Okay students, now students, the first topic is Tyndall effect. You have learned about this topic in your previous class, that is in class 9. So what do you mean by Tyndall effect? It is the phenomenon of scattering of light by colloidal particles which give rise to Tyndall effect. Now Tyndall effect can be observed when sunlight passes through a canopy of a dense forest. Now students, here tiny droplets in mist scatters light. So the color of the scattered light depends on the size of the scattering particles. Now very fine particles scatters mainly blue light, while particles of larger size it scatters light of longer wavelength, students. Now it arises another topic which is color of the clear sky is blue. That is why the color of the sky appears to be blue in color, students. So there is a reason behind this. See students, when white light passes through the atmosphere, then violet, indigo and blue colors encounter suspended particles. Now these waves are absorbed and then scattered and are received by our eyes. So students, in the same way, we can say that the molecules of air and other fine particles in the atmosphere, they have smaller size than the wavelength of the visible light. Now when sunlight passes through the atmosphere, then the fine particles in air scatters the blue color more strongly than the red color. So that is why students, the color of the sky appears to be blue. Okay students. Now students, the next and important topic is why does sun appears to be reddish at the time of sunrise and sunset? The reason behind this, students, near the horizon, sunlight passes through thicker layers of air having larger particles that scatters light of longer wavelengths, such as the red end of the spectrum, okay? Because we have already learned that when refraction through the prism, violet deviates the most and red color deviates the least. So that is why during sunlight, the particle which has longer wavelength, that is the red end, it scatters. So also it travels larger distance at horizon before reaching the earth, as because the red color of the white light, okay, it scatters or it deviates the least, so it reach larger distance at horizon before reaching the earth. However, light from the sun overhead travels relatively shorter distance. So during noon, the sun appears white as only a little of the blue color is scattered, whereas near the horizon, most of the light of shorter wavelength at the blue end of the spectrum are scattered away by the small particles of the atmosphere, students. So therefore, the light which reaches our eyes is of longer wavelength that gives rise to the reddish appearance of the sun. So that is why, students, during sunrise and during sunset, the sun appears to be reddish in color, students. So students, our chapter is completed today, okay? So go through the chapter properly, understand all the topics, understand all the concepts properly, okay? I will upload all the question answers through the PDF. Go through the PDF, okay? Learn each and everything, and after that the topic and the chapter will be clear. Okay students, so that's all for today. Thank you.